Hello everyone, welcome to the Engineering Physics Department at University of Wisconsin-Madison. Hope you are all doing well at this challenging time. My name is Yongfeng Zhang, currently an assistant professor in the Engineering Physics Department. With this talk, I want to introduce you our nuclear engineering program and our research. As you will see, at UW-Madison, our students are well supported, they do excellent research, and will have a bright future. Let me start with some introduction of our university and our department. We are at the city of Madison in Wisconsin, about 1.5 hours away from Lake Michigan. As you can see from the picture at the bottom, we also have a few beautiful lakes surrounding our campus. UW-Madison has about 45,000 students enrolled this year, slightly more than last year, which is very encouraging and means that we are doing strong at this challenging time. As a research-oriented university, UW-Madison has maintained a top ranking in terms of total research expenditure. Our department, Engineering Physics, has about 300 undergraduate students and usually 80 to 100 of graduate students. We have 3 programs from bachelor to PhD. This talk is about the Nuclear Engineering Systems program. Please refer to Professor Carl Sovanek's talk for Plasma Physics and Fusion and Professor Jan Frank's talk for Engineering Mechanics and Astronautics. Our department currently has 21 professors and many affiliated faculties, including 7 named professorships, 1 Wisconsin Distinguished Professor, 4 National Academy of Engineering members. Our nuclear engineering program is ranked 5th nationally according to US News. We have good financial support to our students, including 36 undergraduate scholars, 7 graduate fellowships, and another 85 graduate students supported as either teaching assistants or research assistants. Most important, we commit full financial support during graduate study, as will be written in the offer letters. At the bottom, we have one example taken from previous offer letter. As you can see from the writing there, we provide at least 5 years of financial support. Our graduate students excel during both their graduate study and after graduation. Our students are very competitive in the job market. Many of them work in national laboratories, nuclear industry, or take faculty jobs in other universities. A brand for nuclear energy at UW-Madison is the Institute of Nuclear Energy Systems, or INES. It has 9 faculties from our department who are shown in the top row, and 12 from other departments. INES also has over 100 students who are the main contributors to our research excellence. Because of our dedication to nuclear energy, we are one of the leading institutes for innovative research in nuclear energy. As can be seen from the funding map for the Consolidated Innovative Nuclear Research Program. The CINR program is the most important federal research funding program for nuclear energy. We top nationally in terms of both total funding amount, which is shown by the size of the circles, and the number of projects, which is shown by the color of the circles. We earned this by carrying out outstanding research, and we will continue to do so, hopefully, with you. There are 3 main pieces in nuclear energy research: radiation transport, thermohydraulics, and materials and chemistry. Our research covers all three pieces. For each piece, we have multiple faculties working on it, including current professors, emeritus professors who are still doing active research, showing in the parentheses, and affiliated professors who are showing with a smaller font size. I probably won't have enough time to introduce all the research we do here. Instead, I will briefly introduce a few examples. I strongly encourage you to contact the professors and their students to learn more about their research. For the first example, I want to introduce the research of Professor Paul Wilson. He does radiation transport studies and couples that with computer-aided design to help design advanced fission reactors as well as space nuclear reactors and fusion reactors. Please contact Professor Wilson if you're interested in his research. Professor Ben Lindley's research focuses on designing integrated nuclear and renewable energy systems and advanced reactors for the purpose of improving the efficiency of nuclear power. Here, two examples are shown. On the left is an integrated solar and nuclear system which generate both electricity and water. On the right, what are showing are the innovative enhanced automated control strategies for multi-unit small modular reactors. Please contact Professor Lindley if you're interested. The emails are shown at the bottom right. This slide shows our ion beam accelerator co-managed by Professor Sridharan and Professor Coat. This is a unique facility to simulate radiation damage in materials caused by neutrons in reactors. Radiation damage is the number one concern to material sustainability in nuclear reactors. And it's important to have a facility that can mimic the neutron damage caused in materials as an experimental study. Along with the accelerator, we also have advanced microscopes which are used to characterize the damage introduced into the materials. Please contact Professor Sridharan or Professor Coat if you're interested in radiation damage. Another big challenge to reactor materials is the corrosive environment inside the nuclear reactors because of coolant. Coolants are used to take the power out of reactors, but at the same time, they cause materials corrosion. Professor Sridharan and Professor Coat are working on understanding the fundamental corrosion mechanisms in different environments using different autoclaves, including the CO2 autoclave and also the sulfuric high temperature and high pressure autoclaves. They are also exploring mitigating strategies by designing advanced materials and applying protective coating. A really hot research topic, which UW-Madison is really strong at, is molten salt corrosion. Professor Mark Anderson works on the coolant materials compatibility for various types of salt loops, which are relevant for different reactor designs, as can be seen in this slide. They are also very useful for understanding corrosion mechanisms. I want to mention that Professor Sridharan and Professor Coat are also very well known in conducting research on molten salt corrosion. This slide showing my own research. Complementing the experimental studies, I'm working on degradation of nuclear fuels and materials using multi-scale modeling and simulations. We start from the atomic scale to identify the fundamental physics that are responsible for radiation damage and corrosion, and develop mesoscale modeling tools to simulate microstructure evolution. The change in microstructure is used to estimate the degradation in properties at the engineering scale. A few examples are shown here, including radiation-induced defect evolution and self-organization, and radiation-induced segregation, and multi-scale fracture simulations. Please contact me if you're interested in modeling and simulations. Radiation not only produces damage, it can also provide huge benefit in diagnosing and treating disease. Professor Douglas Henderson has research on neutron transport and dose mapping, for instance, inside a cell body during radiation therapy. This can be very useful to help optimize the treating procedures. Please contact Professor Henderson if you're interested. In doing our research, we have strong collaborations with other universities and national laboratories, such as Idaho National Laboratory, Oregon National Laboratory, Oak Ridge National Laboratory, and many others. This provides great opportunities for using their powerful facilities and for our students to have internships there. With all this, I hope I have given you some information about our university and our department. I want to reiterate that in our department, the students are well supported and they excel in their graduate study and also post-graduation career. Please feel free to contact me or other professors or students if you need more information. Thank you for your attention, and I wish all the best for your future.